Okay, so the recording button is now on. Again, a very good morning to all of you. Welcome to Physics class 6.4 Thin Lens Formula. Okay. So yesterday in the previous lesson, we have learned 6.3 image formation by lenses. So under that topic, you have understand what is, number one, what is the definition for lens. Okay, so if you remember, lens is transparent material. Lens is a transparent material with two surfaces where one of the surface must be a curved shape. Okay, I repeat, lens is any transparent material such as glass, perspex, plastics, okay, where with two surfaces where one of the surface must be curved surface. Okay, then we also have learned there are two types of lenses named as convex lens and also concave lens. And number three, we have learned there are three rules. Okay, there are three rules in drawing the ray diagram for both convex and concave lenses in order to determine position and characteristic of image formed by each lenses according to the position of object in front of the lens. And also yesterday, 2 days before, we have learned also we have do some question involving problem solving on image formation by lenses. Okay, so for today we are continue with the fourth learning standard. 6.4, the fourth content standard in chapter 6, thin lens formula. Actually, this is a very short subtopics, students. So we are going to play with thin lens formula, and there is one thin lens formula for you to know and understand very well. Okay, so let us go to our first learning standard. It is an experiment 6.4.1 to investigate the relationship between object distance and image distance for convex lens. And then second, to determine focal length of a thin lens by using this formula. Okay. So this is the formula for thin lens. 1 over F equal 1 over U plus 1 over V. So before we go more detail on this formula and look at the applications, so let us take a look first at this slide. Okay, you can see there are two diagrams here. Okay. Sorry, this is the image of a toy car. So for the first situation, you can see there are two images there. So this situation involving image for different object distance, okay, with the camera lens of the same focal length. So in these two diagrams, we are using camera with the same focal length. The focal length of the camera is 24 millimeter. The second camera also 24 millimeter. But the difference is, for the first camera, the object is placed 0.5 feet in front of the camera. Okay. And for the second diagram on the right, the camera is placed 1 feet from the object. Mean here the object distance is 0.5 feet, the left diagram. And the right diagram, the object distance is 1 feet, okay, which is further from the camera. So you can see the image produced will be different in size. Okay, for this one, camera with the shorter object distance will produce bigger image. Okay, the image is larger compared to the second camera where the object is further from the camera. So the size of the image produced is smaller. Okay, so here we understand a short distance object produce larger image, okay, while a long distance object produce small image. Okay, and from this situation later you will understand object distance, image distance and focal length can be relayed through this equation. 1 over F equal 1 over U plus 1 over V. Okay, so this is situation A. And then student, this is the second situation. Okay, now we have camera with the same object distance. But now the camera has different focal length. Okay, now U is the same, but F is different. Okay, so for the first camera on the left side, the focal length is 24 millimeter. F, 24 millimeter. For the second camera, F, focal length is 60 millimeter. It has longer focal length. So here you can see what happened when the camera has a shorter focal length, the image produced by the camera will be smaller. Okay. Meanwhile, camera with longer focal length will produce larger or bigger image with the same object distance. Okay, so this is situation A and situation B. The difference between the first one when we have camera with same focal length but different object distance. And second situation, a camera with same object distance but different focal length. Alright, okay, then this is a few more example of image, okay, can be catched on a camera with different focal length. Okay, all objects are captured from the same distance. Mean object distance is the same, but all camera has a different focal length. Okay, this one 14 millimeter, 24 millimeter. This is 35 millimeter. Okay, 50 millimeter. This one with 70 millimeter. Okay, 85 millimeter, 135 until 400. So you can see here, when the focal length increases, the image also increases. The size of the image also increases. Okay, so longer focal length will give you bigger magnification or bigger size of image. Okay. Okay, then this is the experiment relate U, V, and F. Okay, experiment 6.3. You can find this in your textbook as well with this arrangement of apparatus and material. So we are using convex lens placed on a lens holder and it is placed in front. This is our object. Okay, and there is a white cardboard here. It is poked with the triangle and we place a light sources down here. So this triangle will act as our object. Okay, and you will see the white screen will be adjusted until we can see sharp triangle image on it. So that will give you image distance. Okay, and then we can calculate what is the focal length of this convex lens. Okay, so this is the inference. Image distance is influenced by object distance, which means in this experiment, when we change U, V will be changed later. Right? Okay, and the hypothesis, when the object distance increases, the image distance decreases. Okay, which means U is inversely proportional to V. Okay, and the aim is to study relationship between U, V for a convex lens, where U is the object distance and V is the image distance. And finally, we can determine focal length of this lens by using formula of 1 over F equal 1 over F equal 1 over U plus 1 over V. Okay. Okay, this is all the related variable. MV is object distance, RV image distance, and our constant variable is focal length. Means we are using lens with the same type and same thickness. Okay, and arrangement of apparatus as you can see here. Okay, convex lens, lens holder, a bulb, wooden block, white screen, and meter rule. Okay, student. So this is the procedure, very simple. We switch on the bulb, adjust the position of the lens until U 15 centimeters. So this is the first object distance we are using. And then we adjust the screen in order to form a sharp image on it. Then we measure the distance of image V using ruler. And we repeat this experiment by using different object distance of 20 cm, 25 cm, 30 cm, and 35 cm. Okay, and this is the example of result you might get from this experiment. So if you go to your workbook, page 137, the experiment is there. Okay, workbook, page 137, experiment 6.3 in page 137 until 139. Okay, later we will check this on school next week. Okay, then for U15 until 35, so this is the image distance measured from 30 to 14. So here you can see obviously when U increases, V is decreases. Okay, and this is to calculate 1 over U. How we get 0.067? 1 divided 15. Okay, this is 1 over V. How we get 0.033? So 1 divide 30. So the rest follow. Okay, this one 1 divide 20 give you 0.05. Here 1 divide 20, so give you 0.05. Okay, then so if you look at the GIF here, so this is what happened in this experiment. Okay, you can see that when we adjust the object distance, when the object distance is closer to the lens, you can see the image distance is increases. Okay. Okay, so this is the example of analysis of data. So we plot a graph from our table. So 1 over U is our x-axis. Okay, 1 over V is our y-axis. So we plot a graph of 1 over V against 1 over U. So this is the pattern of graph you should obtain. Okay, the pattern of graph for 1 over V against 1 over U. Okay, so from here, when you calculate the gradient, mohon perhatian kepada pemilik kereta PHT 4957. Okay, we let the announcement first, okay? Mohon perhatian kepada pemilik kereta PHT 4957. Harap dapat ubah kenderaan anda dengan segera. Terima kasih. Okay. Okay, sorry for the interruption. So we continue with our discussion. Okay, so this is the graph we plot earlier. And here is the gradient of the graph. So this triangle shows the gradient of the graph. So we take the first point and this is our second point. Okay, so gradient y2 minus y1 divide x2 minus x1. So here you find the gradient negative 1.0. Okay, negative 1.0. Okay, then from this formula of thin lens, formula, okay, 1 over f equal 1 over u plus 1 over v. And this linear equation formula, y equal mx plus c. So how we are going to equivalent this formula? Okay, students, so this lens formula we have to arrange. Okay, so our y is 1 over v. So we put y here. Okay, 1 over v is y. Okay, and our gradient, we calculate earlier is negative 1. This is our gradient, negative 1. Okay, and our x is 1 over u. Okay, so m gradient negative 1 and x is 1 over u. Okay, so this is x, 1 over u, which means c, the intersection of this graph will be our 1 over f. Okay, so this is intersection 1 over f. The intersection y-intercept of this point is 0.10, which means 1 over f is c. Okay, so y-intercept is 1 over f. The value is 0.1 from this graph. So from here, we can find our focal length. Okay, focal length is 10 centimeter. So 1 over f equal to 0.1, which means f is, so you bring f up here. So 0.1 you bring down. So 1 divide 0.0 will give you 10 centimeter. Okay, so from here, from the experiment conducted, from the data collected, and from the analysis of data made, we can find the focal length of this lens is 10 centimeter. Okay, are you clear on this calculation? Especially how to equivalent the thin lens formula with the linear equation formula in order to determine the focal length of the lens. Okay. Okay, next students. Okay, so this is the conclusion we can make from this activity. Number one, if you see the graph of 1 over V against 1 over U shows that 1 over V decreases linearly. Okay, so the pattern is 1 over V decreases linearly. Okay, this is not an inversely proportional graph. Remember, we learned earlier, if the graph is inversely proportional, this is the pattern. Okay, so for this one, we just say 1 over V decrease linearly with 1 over U. Okay, which means when the object distance increases, so the image distance decreases. So from here, we have proof the hypothesis is accepted, where when U increases, image distance decreases. Okay. Okay, so this is the safety precaution that we took when conducting this experiment. Number one, when you are taking reading from the ruler, so eye position must be perpendicular to the scale of the meter rule. This is to avoid parallax error. So we will get an accurate reading. Okay, and second, this experiment should be conducted in a dark room condition. So it is easier to see the image form on the white screen. Okay. Okay, students, so let us take a look at one example here relate to the experiment we discussed just now. Okay, now we have this diagram. Okay, it shows a ray diagram for an image. So this is the image I, formed by an object. This is the object O, placed at the distance of 15 centimeter in front of a convex lens. So from this information, we understand this 15 cm is refer to U, object distance. Yes, very good. So our object distance is U, 15 cm. And you can see there are distance here given from the object to this image. Given the distance is 75 cm. So what can we get from here? Okay, actually from here we can find the image distance. So how to find image distance? 75 centimeter minus 15 centimeter. Image distance is here from the lens axis or from the optical center to the image. So this is V. So how to find V? 75 minus U. U is 15, which means our image distance is 60 centimeter. Alright? Okay, so the question here asks, name the light phenomenon involved. So can you name the light phenomenon involved here, students? What is the light phenomenon involved here? Is it reflection? Is it refraction? Or which one? Which phenomenon? Okay, let us see some answer. You may share your answer. Type in the info messages. What do you say? Okay, so the phenomenon is refraction of light. Yes, so the phenomenon involved for lens is refraction of light. Okay. Second, they ask you to find the focal length of this lens. So how to find focal length? Okay, so remember our thin lens formula, 1 over f equal 1 over u plus 1 over v. Okay, so this is the diagram related. So this is our information. U is 15 centimeter. V, 75 minus 15, which is 60 centimeter. Okay, so this is our formula. So 1 over F, 1 over 15 plus 1 over 60. Okay, so it will give you F of 12 centimeter. So our focal length is 12 centimeter. Okay. Okay, then second question, find the height of the image if the height of the object is 1.2 centimeter. If you remember, this is what we discussed in the previous lesson involving linear magnification. Okay, involving linear magnification. Given the height of the image, Okay, we are looking for the height of the image and given the height of the object 1.2. So remember the formula for linear magnification. Who remember? Okay, M is equal V minus V over U equal to HI divide HO. Okay, linear magnification. You can check the formula also in your workbook, page 136. 136 in question number 4 there. Okay, formula for linear magnification. M equal HI divide HO also equal to V divide U. Okay, so this is the formula we are applying. Given the height of object 1.2 cm. Okay, V is 60. U is 15. So from here we can find height of image from this relation. Height of image divide height of object equal to image distance divide object distance. So you just do the substitution. So HO 1.2, V is 60 and U is 15. So we'll give you height of image 4.8 centimeter. Okay, for the second answer. All right. Okay, next. The third question. Predict what happened to the image form when the object is moved closer to the lens until it is at the distance equal to the focal length. Okay, so previously from the diagram, you can see we place our object 15 centimeter from the lens, and this lens has a focal length of 12 centimeter, which means now the object is in between F and 2F. Okay, object now is in between F and 2F. So the third question, we move our object closer until U equal to F. Okay, mean U equal to F. U equal 12 centimeter. So the question asks you predict what happened to the image form. Okay, so what will happen? This will be the image form. Okay, when U equal to F, which is at 12 centimeter from the lens. Okay, so this is the ray diagram. Draw according to the rules of drawing the ray diagram. First one, we draw a straight line from the object towards the optical center, the yellow line. So it will not refracted, continue travel in a straight line. And then we apply the second rule of drawing the ray diagram, the red line there. Okay, a straight line parallel to the principal axis. After passing through the lens, it will be focused at the focal point F there. So you will see that these two ray diagram will be parallel, mean there is no chances they will intersect either on the left side or on the right side. So where is the image form at here, student? For this ray diagram. So the image will form at infinity. Okay, so the image form is real, inverted, magnified. Okay, the image form is real, inverted, magnified, and distance of the image increases further from the lenses. Okay, and then when U is equal to F, so what happened? The image will produce up here, virtual, upright, magnified, and form at infinity. Okay, earlier when you move from distance 15 closer or towards the lenses, so this is what happened. The image will form on the opposite side, real, inverted, magnified. And finally, when it reach F, here as shown in this GIF, okay, when it reach F, see, no image produced, which means the image is formed somewhere up here at the infinity with the characteristic of virtual, upright, and magnified. Okay, so this is the changes of characteristic of image occur when we move the object closer towards the lenses. Okay, from distance between F and 2F until it reach distance equal to F. Okay. Okay, then that is to do with the first learning standard. Okay, now we enter the second. Okay, second learning standard is to solve problem using lens formula for both convex and concave lenses. Okay. Okay, first let us take a look at this. Can you please turn to your workbook page 137? Okay, workbook page 137. Okay, I want you to complete number 1. Okay, the thin lens formula, right? The thin lens formula on box provide that in page 137. Number 1 thin lens formula is 1 over F equal 1 over U plus 1 over V. And you please write what is U. So U is object distance. What is V? V is image distance. And F is focal length. Okay. Again, in your workbook, page 137, okay, you can complete the thin lens formula there together with the uh, blank spaces for U, V, and F, right? What is U? U object distance, V image distance, and then F is the focal length. Okay, students. Number 2, this is the rules on using this lens formula. Okay, the rules of using the lens formula. Okay. For 2A, you please write there positive. Okay. 2A, A is positive. And then for BB, you write there negative. Okay, negative. Okay, in your book, you have U, V, and F there in table number 2. Okay. For object distance, for both concave and convex lenses, object distance is always positive. Okay, object distance is always positive. Object distance is always placed in front of the lens. Okay, so it is always positive, the value, remember. Okay, and then for V, okay, for V, if later when you use this formula, when you find V positive sign, okay, so it means that the image produced is real image. Okay, and then when you calculate V, if you find the value is negative, it shows that the image produced is a virtual image which is on the same side as the object. Okay, and student, for focal length, remember for convex lens it has positive focal length. Okay, I repeat, for convex lens it has a positive focal length, mean it has a real focal length. Meanwhile, for concave lens it has negative focal length. Okay, the focal length is virtual. So when you use this equation, if the situation involving convex lens, F will be positive. Okay, if you are using concave lens, the value for F must put negative sign. Okay, later we will see example of questions so you will understand more detail or more clear on that. Okay. Okay, example here. Before we go to the exercises, we check first image formation for convex and concave lens. So these two GIF shows to you for convex lens. When we change the position of object, you can see the characteristic and position of image is varies. Okay, depend on the object distance. So you may check your textbook on 6 different places where we can put object distance, which give you various characteristic of image. Okay, so as written here, position and characteristic of image for convex lens is varies with its object distance. Meanwhile, for this concave lens, student, the GIF on the right side, okay, you can see wherever we place the object at, the position and characteristic of image always virtual, upright, and diminish. Okay, it is always formed somewhere here at the position less than the focal length. Virtual, upright, and diminished. Alright? Okay. So let us check this exercise. Okay. Actually, you can find this exercise also in your workbook. Page 140, question number 3. Okay, are you there? Page 140, 140, page 140, question number 3. Okay, solve problem involving thin lens formula. Okay, we have an object which is placed 30 centimeter from a convex lens. So you may highlight 30 centimeter convex lens. And given the focal length of the lens is 20 cm. So we have a few information. We have few information here. Okay. The question is how far from the lens is the image? So means the question here asking for V, image distance. So this is the diagram related to this question. Okay, this is our convex lens. The object is placed at the distance U. So U is 30 centimeter. Okay, and this is the image formed at the opposite side. So our image is real, right? Okay, then so how far from the lens is the image? So this is the information given. Okay, you remember U for both lenses always positive. Okay, U for both lenses always positive. F depend on lens. Okay, for convex lens, the focal length is positive. Okay, and for concave lens, F is negative. Okay, so this is the thin lens formula we are applying. 1 over F equal 1 over U plus 1 over V. Okay, so we do the substitution. 1 over F is 1 over 20. 1 over U, 1 divide 30. Okay, divide 30. See positive value. And here 1 over V. Okay, so we are looking for V. So we rearrange this formula. So V will be 60 centimeter and somehow you find the value is positive. Okay, positive value mean our image is real image formed at the opposite side of the object. Okay, with the distance of 60 centimeter from the optical center. So here we understand from the calculation using thin lens formula, this distance V is 60 centimeter. Okay, 60 cm, where U is 30 centimeter and the focal length 20 centimeter. So, are you done? Question 3A1 on page 140 in your workbook. So the image distance is 60 centimeter. Okay, second question, they ask you what is the linear magnification form? Okay, so can you find linear magnification? Remember the formula linear magnification, M equal V over U. Or you can find M equal HI minus HO. So in this case, we have V, we have U. So we can find the magnification produced. So M equal V divide U. V is 60, U is 30. So answer is 2. Okay, 2. So what is meant by 2 here? So remember, when M is greater than 1, we understand the image is magnified. Okay, when you find M equal to 1, what happened? The size of object same with the size of image. Okay, and when you find M less than 1, it means yes, the image is diminished or smaller than the object. So here we find M equal to 2. So we understand the image is magnified twice. 2 here means it magnified 2 times, twice of the size of the object. Okay. Then what is the characteristic of image? This is the third question. Similar to your workbook, also question number 3. A3, what is the characteristic of image form here? So you can write 3 characteristics. Number 1, virtual or real. Okay, virtual or real, remember? So it is formed at the opposite side of the object. So it should be real. So this side is real image. If formed on the same side of the object, so it is virtual. So first, the object is real. And then, is it upright or inverted? Object is above principal axis, but our image is below principal axis. So we understand the image is inverted. And from the magnification of 2 here greater than 1, we understand the image has been magnified. So the characteristic, real, inverted, and magnified. Okay. So you write there real, inverted, and magnified, right? Okay. Okay, next question number 2. Okay, question number 2 also similar to question 3B in your workbook. So you can check that. Now we are given with concave lens. See, concave lens with object distance 30 centimeters. Sorry, object distance 30 centimeter. This is the object. And the focal point of this lens is 20 centimeter. Okay, so the first question again, find the image distance. How far from the lens is the image? So can you find the image distance? Can you calculate and share your answer in the in-call messages? Then you can compare the answer with mine, which I show you later in this screen. So you write first. Okay, write the information given first and then write the applicable formula, which is the thin lens formula. Do the substitution and then find what is V. Okay. If you are done, you can share your answer in the in-call messages. What is the value for V here in question 2? Remember, we are given with concave lens. So what happened to F? F must have negative value. Okay, negative 20. The negative sign must be put in the equation. Okay, let us see who's done with this. You may share your answer in the in-call messages. Okay, nobody sharing answer yet. Can you try first? Calculate. So the formula is 1 over F equal 1 over U plus 1 over V. So you just do the substitution. So 1 over F is 1 over negative 20. So equal to U 1 over 30 plus 1 over V. Okay, so find what is V. Did you get negative 12 centimeter? Okay, so if you substitute correctly, so 1 over V is negative 1 over 20 equal 1 over 30 plus 1 over V. So we find for 1 over V, we make it as our subject. So your answer will be negative 12 centimeters. So remember, when V is negative, negative sign here shows that the image produced is virtual. Remember, when V positive, it produced real image. When V negative, it produces virtual image. Virtual image means the image produced at the same side of the object, which is in front of the lens. So from our answer, we understand V equal negative 12 centimeter means the image is located 12 centimeter from the optical center of the lens and it is produced on the same side of the object, which is virtual, right? So second question, again, what is the magnification does the lens produce? So magnification, M equal V minus U. Okay, so for magnification, since we are finding ratio, so this one, we ignore the negative sign, okay, for magnification, since we are looking for ratio. So the positive negative sign does not give any effect because it is a division. So 12, this is the image distance, divide U object distance 30. So you will find 0.4. M equals 0.4. Remember, M now less than 1. So less than 1, we understand the object is, the image is diminished. Okay, mean size of image smaller than size of object. So from here, we can write the characteristic of the image. Okay, virtual, upright, diminished. Okay, from calculation, V negative, we understand it is virtual. From the calculation of the magnification, we understand the image is diminished because less than 1. How to know the object is upright? Okay, remember I tell you before, virtual is always paired with upright. Okay, and real image is always paired with inverted. All real image are inverted. Okay, all virtual image are upright. So that is the pair. View-re. You can use the short term view-re. Virtual, upright, real, inverted. View-re. V-U-R-I. Right? Okay. Then students, okay, this is the third question. Okay, third question. Okay, this is not in your workbook anymore. Only two questions there in your workbook 3A and 3B. Okay, so let us do this together. Now we are given concave lens. Okay, so you can highlight concave lens. Remember, F is negative. Okay, focal length 25. Mean F is negative 25. It form virtual image. So virtual image. So we understand V here is negative. Okay, of an end at a distance of 20 centimeter from the optical center. So see, V is negative 20 since it is virtual, and F negative 25 since this is concave lens. So the question asks, what is the original position of the end? Which means we are looking for object distance. Okay, so how to find object distance? Thin lens formula. Okay, 1 over F equal 1 over U plus 1 over V. So you just substitute. This is 1 over F with negative there. 1 over U, you are looking for this U. So plus negative. Okay, V here is negative because virtual. So it will give you, you do the you solve this, so you will find U is 100 centimeter, which means the end is 100 centimeter in front of the concave lens. Alright, okay, then B, they ask you to draw the ray diagram to show the formation of virtual image of the end. So this is the ray diagram related. Okay, so this is the symbol for for concave lens. Okay, for concave lens. For convex lens, okay, convex lens, this is the symbol for convex lens. Okay, convex lens. This is the symbol for concave lens. Okay, actually if you continue this line, so it will form convex lens. Okay, here if you join these two ends, so it form concave lens. Okay, so that is the symbol for both concave and convex lenses. So we draw. So we draw the lens first, concave lens, and this is the focal length. Focal length is 25 centimeter. Okay, this is 25 centimeter. Object distance is 100 centimeter. So this is object distance 100 centimeter. Okay, and the image is formed 20 centimeter from the optical center, and somehow it is virtual. Okay, then we draw the ray diagram. First, ray diagram from the object to the optical center, not refracted, continue travel in straight line. Okay, second rule, we draw a ray diagram from the object parallel to the principal axis. This is the principal axis. Okay, then it is diverge out. See, remember, concave lens is a diverging lens. So it diverge, refract the light ray outwards as it is come from the focal point at the front. So this is the intersecting point of these two ray diagram where our image form at. So you can label with I or right there, image. Okay. Okay, next question, students, number 4. Okay, so this diagram now. Okay, again, our lens here is convex lens. Okay, this is where we place the object at a distance of 9 centimeter from the lens, which means U is 9 centimeter. And this is the two ray diagram drawn based on the first rule, passing through optical center, and then the second rule, parallel to the principal axis and focusing on the focal point. So this is the intersecting point of these two light ray where our image is formed at. Okay, so from the image you can see it is real image. Why real? Form on the opposite side with the object, and it is inverted. Okay, so real, inverted, and the size you can compare, it is magnified. So our image is real, inverted, and magnified. Okay, now find the image distance. Okay, again, find V. So, thin lens formula. U, 9 centimeter. F, positive 6. Y, positive? Convex lens. Okay, positive focal point. So here you will find V, 18 centimeter. Positive 18 centimeter. See, it is real image, positive. So, image is located 18 centimeter from the optical center of the lens on the opposite side of the object. Mean it is real. Okay, now find the height of the image. Again, how to find height? We can use the magnification formula. M equal V minus U. Equal to V divide U. Okay. So we are using this. Okay. Find the height of the image. So we want to find HI. Okay, HI. Okay, from here the information given the height of the object is 2 centimeter. So we have three information. HO 2 centimeter, U 9 centimeter, and V 18 centimeter. So from here we can find HI. So we replace. HO is 2, V is 18, U is 9. So it will give you a height of image of 4 centimeter. Okay, 4 cm. Is it correct? 4 cm. 18 divide 9 and then multiply 2. Okay, 8 centimeter. Okay. Okay, then next question. Okay, next question. You are given this diagram. Diagram A. It shows the apparatus used to determine relationship between object distance, image distance, and the focal length of a convex lens, as in experiment 6.3 earlier. And this is the result of the experiment shown in diagram B. So a graph of 1 over V against 1 over U is plotted. And from this pattern, it shows that 1 over V decreases linearly with 1 over U. This is the 2-point mark on this graph. The first point up there, 0, Q, the coordinate. And the point here is P0, the coordinate. Okay, the first question. What is the value of Q, student? Okay, what is the value of Q? So Q is the y-intercept. Okay, so remember from this graph, y-intercept represent the y-intercept. Remember, okay, so this is the clue from this thin lens formula and linear equation formula. So Q is the point where it is the y-intercept. Okay, so which is C. So C here is 1 over F. Okay, so Q is 1 over F. Okay. Okay, question 6. I think this is the last question for exercises on this topic, 6.1. This is from previous SPM, not previous, past year SPM question. Okay, long time ago, okay, long year ago. So figure 6.1 give you image of the letters Phi. Okay, the K is missing because it has been magnified. So K is out of the range. So letters Phi, F-I-Z-I, when viewed through a glass of water. Okay, so this is the actual object. Okay, the actual spelling for strategi pengajaran fizik untuk guru sains. This is the image appear on the glass. Okay, so the first one state the light phenomenon that causes the image Phi to be enlarged. Again, asking for phenomenon. So what is the phenomenon here? Answer is yes, refraction of light. Refraction of light. Okay, next question B. What is the change of size of image if the water is replaced with a transparent liquid of a greater optical density? Okay, what do you think will happen to the size of image? Now we fill this glass with water and this is the size of the image appear. Okay, now we replace the water with different liquid of greater optical density. So what do you expect happen to the size? will be enlarged somehow, or will be smaller than what we can see now, or no changes in the size? What do you think? Any idea? Okay, so what will happen? So the size of image will be increases. Okay, size of image increases when we are changing the water with the transparent liquid of greater optical density. Okay. Okay, then C, question C, student. The glass of water is replaced with a lens M. Okay, now we took the glass and we put now lens M there with a focal length of 10 centimeter. Okay, the distance between the book cover and the optical center is 8 centimeters. So this is U object distance, F 10 cm. Okay, then it says it is observed that the image physics is enlarged. Okay, it is observed that image physics is enlarged. So this is a very important information. The first question, name the type of lens M. Okay, so what type of lens is lens M? Convex or concave lens, student. Okay, the keyword is here. Image physics is enlarged. Okay, so what type of lens M here? Okay, if you are given this kind of question, you just remember for concave lens, remember the characteristic of image always virtual, always upright, always diminished. So lens M cannot be concave lens. Okay, it can't be concave lens because it written here the image is enlarged. So lens M should be a convex lens. Okay, it should be convex lens. Okay, then second, find the distance of the image from lens M. Mean find image distance V. Okay, so we can apply the thin lens formula. So U 8 centimeter, F positive 10, Y positive convex lens. So now we are looking for V. Okay, so you do the substitution 1 over F, this is 1 over U, this is 1 over V. So somehow you will find V will be negative 40 centimeter. So what do you understand from this value? Negative 40 centimeter. So there are two information here. Number one, we understand the image distance is 40 centimeter from the optical center. Number one. Number two, since it is negative, so we understand the image is virtual. Okay, the image is virtual, mean it is produced at the same side of the object. Okay, V negative give you virtual image. Okay, and the third question, determine the linear magnification of the image. So again, M, okay, V over U. V divide U. So V 40. Remember, for ratio, we ignore the negative sign, okay, because it does not affect our ratio. So 40 divide 8. 40 is image distance, 8 is the object distance. So it will give you 5. So now M greater than 1, which is 5. So we understand the image is magnified. How many times? 5 times bigger compared to the actual size of the object. Okay, so this is, we have solved question C. The type of lens is convex. Okay, this is the image distance and this is the magnification. So lens M here act as a magnifying glass. Okay, it act as a magnifying glass. Okay, so that's all. Thin lens formula. Okay, very simple, very short. Only one formula related there. Okay.